Hi, good morning. Today we're going to review the FTC, the average value of function and derivative of integral. So the first one we're going to review will be the fundamental theorem of calculus, which is called the FTC. So let's take a look at what the theorem say. Integral a to b f prime of x dx equal to f of b minus f of a, where f of x is an antiderivative of f prime of x. Antiderivative, derivative. We can apply FTC in different situations. In other words, we can have different version of it. Example, if the derivative of g of x is g prime of x, then the integral a to b g prime of x dx equals g of b minus g of a. Derivative, antiderivative. If the derivative of g prime of x is g double prime of x, then the integral a to b g double prime of x dx equals g prime of b minus g prime of a. Derivative, antiderivative. The antiderivative of the second derivative is the first derivative. So let's take a look at another problem, okay? Problem number 1. Okay, problem number 1. So we have a table. It said that v of t is twice differentiable function and selected value are given. V of t is the velocity of an object moves horizontally on the interval 0 to 12 seconds. Find the value of the integral 0 to 12 a of t dt. Explain the meaning of the integral 0 to 12 a of t dt in terms of the object's motion. So now let's take a look at the question over here. We're supposed to find the value of the integral 0 to 12 of a of t dt. Okay, so we need to find the integral 0 to 12 a of t dt. So we know that this represents the area under the curve of a of t, but we do not have the graph of a of t, and we do not have the function a of t. We had the v of t given to us. So if you want to find the value of this, so that means you're forced to use the v of t. The FTC relate the derivative and the antiderivative together. So a of t is the v prime of t. So a of t is the derivative of v of t. So they are related together. So we can use the FTC to put all them together. So only that FTC, okay, can relate derivative and antiderivative at the same time. So now we have integral 0 to 12 a of t dt. So the antiderivative of a of t is v of t. So you get v of 12 minus v of 0. So now we look at the table. So we have v of 12, which is 60, and v of 0, which is 40. So we subtract, we got 20, and the unit is meter per second. So that means the integral 0 to 12 a of t dt is 20 meter per second. So now the question asks you, okay, explain the meaning of the integral 0 to 12 a of t dt in terms of the object's motion. So based on this, we did not learn anything special about this integral a to b a of t dt. But we look at here, this turn into v of 12 minus v of 0. Basically is the difference between the two velocity. So we say that it represents the change in the velocity of the object. So we're going to look at more closely. Change, it means either increasing or decrease. Okay, change means increase or decrease. So 20, okay, from 40 to 60. So we can say that the velocity increases 20 meter per second from t equal to 0 to t equal to 12 seconds. So you have more specific of the change. One more time, change means increase or decrease. Now we finish problem number 1. Let's take a look at question number 2. Question number 2, we have done this question for homework if you had read the homework assignment. So this question is talk about, as a part of T cruise, the temperature of the T is modeled by a differentiable function h, and in the interval 0 to 10, okay? And h is measured in degrees Celsius. So let's take a look at the focus that we are going to talk about today, which is part C. Evaluate the integral 0 to 10 h prime of t dt. Use correct unit. Explain the meaning of the expression in the context of this problem. You have integral 0 to 10 h prime of t dt, h prime. And the table is h. There's no function of h primes given. There's no graph of h prime at t given. So you cannot find the area under the curve. You cannot use the equation to do integration. So you are forced to use the ht, the antiderivative. Only the FTC can relate the derivative and the antiderivative together. So we say that 0 to 10 h prime is t dt. The antiderivative of h prime is h. So we have h of 10 minus h of 0. So one more time, the FTC connect the derivative and antiderivative together. So now we have to find the value of this. Now we have to use the table to figure out what's h of 10, h of 0. So h of 10 is 43 and h of 0 is 66. So now we calculate it, okay? So 66 minus 43, you got 23 and negative. The question asks you to find the unit. The unit of h is degrees Celsius. Degrees Celsius subtract degrees Celsius, you still get degrees Celsius. So now we found the value of this. So therefore 0 to 10 h prime of t dt equal to negative 23 degrees Celsius. Now, what does this represent? So this whole question is talking about the temperature of the T. So we're going to use the same concept of the previous question. So we just did h of 10 minus h of 0. We found the difference. Okay, we subtract, we found the difference between the temperature. So we call it represent the change in the T temperature. So change, okay, it means either increase or decrease. So now we're going to make it more specific. So you have negative 23 from 0 to 10. It decreased, okay, so it represents the T temperature decreases 23 degrees Celsius from t equal to 0 to t equal to 10 minutes. So one more time, change either increases or decreases. So in this case, it decreased. Now if we finish question number 2. Let's take a look at question number 3. So number 3, we have a graph over here. So let's take a look at this. A car is traveling horizontally. Car's acceleration function at is given on the interval from 0 to 7 hours. V is 0 equals 60 miles per hour. Find the value of V of 7. The graph of at is given. V is 0 is 60. V7 is the one you're looking for. Derivative, antiderivative, derivative, antiderivative. Only the FTC can connect the derivative and antiderivative together. So in this situation, so we are going to use FTC again. So we have the 0 and 7, and then derivative is A of t. The antiderivative is a V of t, so V of 7 minus V of 0. Now over here, this one represents the area. Under curve. There's no table, so I already used the area under curve. So now we are going to take a look at this. We have to find the area. Okay, so you have here and then here. So we have to find the area from 0 to 7. So we had this part above the x-axis, and then you had this part, okay, below the x-axis. So over here, there's something very special. So some people may notice already. 1, 2 unit, 1, 2 unit, 3 unit. In here also 3 unit. So this part. So this is A and this is B. Trapezoid A and trapezoid B, they have the same area. So they cancel each other. So now that means we can say that the integral 0 to 7 A of t dt equal to this part left over. These cancel equals 0. So the extra part will be this. So equal to the integral from 4 to 7. A of t dt. So now we are going to calculate the area for the leftover part O. So we got 1, 2, 3. We got 3. And here, okay, this is 5, comma negative 3. So it will be 1. And the height is going to be 3. So we are going to do is negative 1/2 base 1, which is 3. Base 2 is 1. And the height is 3. Equal to V of 7 minus V of 0. So somebody may ask, how come it's using negative over here? Negative because this part is below the x-axis. So therefore I have to use negative. This positive, this negative, they cancel each other out. So only this part's left over. Now I'm going to simplify. So I get 4 times 3. Cancel, you get 2. So negative 6. So we have 7. Let's take a look at V of 0. V of 0 was 60. So I put 60. And I'm going to add 60 both sides. So V of 7 equal to 54. And if you want to put the unit, it'll be miles per hour. So we finished question number 3 using FTC. Let's take a look at question number 4. Number 4. So this question was from the homework question on the 4/23. So let's take a look at this question over here. So this question asks you, the function f satisfying, okay, f is 0 equal 20, the first derivative of the f satisfies the inequality. F prime of x is between 0 and 7 inclusive for all x in the closed interval 0 to 6. Selected values of f prime are shown in the table above. The function has a continuous second derivative for all real numbers. So now we had the f prime of x given to us. Let's take a look at part A. Part A says, use a midpoint Riemann sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of f of 6. You need to find f of 6. In the information tell you f of 0 equal to 20. in the table of f prime of x is given. So one more time, only the FTC can put all these three things together, okay? You have your derivative, you have the two parts that form the antiderivative. Only the FTC can relate them together. So you get 0 to 6, the derivative, and equal to antiderivative, okay, f of 6 minus f of 0. Now, we know that f of 0 equals 20. We can do substitution. But in this part over here, we cannot substitute the equation to calculate. We have to find the area underneath the curve. But there's no curve. And there's a table given to you. So there was a table given to you, then you have to use the approximation. They told us to use a midpoint sum. So therefore we have to do a midpoint sum. So now let's go a little bit closer to the graph and then take the table. So we are going to find the midpoint sum. 3 subintervals. Okay, so we had 0 to 2, 2 to 4, 4 to 6. The middle will be this one. The middle will be this one. The middle will be this one. So now delta x equal to 4 minus 2, delta x equal to 6 minus 4, delta x equal 2. So to use the Riemann sum, midpoint Riemann sum, that means you do base times height, rectangular approximation. Delta x is a base times the height. The height is the f of x. Okay, so if you remember. So now over here we have 1, 2, 3, 3 rectangles. The first one, the base is 2, so 2 times 3.5, that's the height. Next one, it will be 2 times 0.8. The third one, that will be 2 times 5.8. And then f of 6, f of 0, it was 20. So now over here, you're going to use a calculator, and you're going to get 20.2. Okay, when you take the AP exam, don't forget to use a calculator. So now we are going to have f of 6 minus 20. And then plus 20 and plus 20. So you get 40.2 equal to f of 6. So we finished the part A using FTC in incorporation with the Riemann sum. One more time, Riemann sum is base times height, delta x times the y value. Now let's take a look at next part. Part B. Determine whether the actual value f of 6 could be 70. So what we did in part A is this approximation. So definitely, okay, so the actual value is unknown over here. So before we said that if you have a left sum, if you have increasing function, you're going to be underestimate. If you right sum, you'll overestimate. But over here, you don't know. It's going to be increasing, decreasing, and then you cannot tell, okay, by using increasing, decreasing. Here, something special given to us. This part was given to us. So there's a reason they give it to us. The question wants us to use this one. If f prime of x less than or equal to 7, okay, of course greater than or equal to 0. If you want it could be 70. So we approximated before, okay, it was 40.2. So let's definitely we're not going to look at the lower limit. We're trying to see what's going to be the upper bound. So we're going to use f prime of x less than or equal to 7. So what it means is, if you do it graphically over here, it is y equal to 7. F prime of x is going to under it, okay? So 0, so 6, so this is 4, okay, something like this, okay? So this is f prime of x. So f prime of x is less than or equal to 7. So now, that is how it looks like. But you want to find the value f of 6, see if it's going to be, okay, equal to 70 or not. So the only FTC can turn the f prime of x into the f6. This the derivative, this is the entire derivative. So that only using integral 0 to 6 f prime of x dx can turn this into f of 6 minus f of 0. So therefore, I have to use the integral on the left side. Then I had to do the integral 0 to 6, 7 dx on the right side. So some people say that, are these going to be balanced? The answer definitely yes. This means the area underneath the curve. So you find the area underneath the curve. And then you have the integral 0 to 6. That also means the area. Okay, the area of the rectangle underneath the curve. And then this is going to be the area of the f prime of x underneath the curve. It's still going to be whole. Okay, this relation is still going to be true. So now I'm going to continue over here. So some people may do, okay, this is going to be 6 times 7. I'm going to integrate it, okay? So we get f of 6 minus 20 less than equal to 7 times 6 minus 0. So f of 6 minus 20 less than equal to 42 and plus 20. So f of 6 is going to be less than equal to 62. So f of 6 is going to be always less than or equal to 62. So that means f of 6 could not be 70 at all. So we finished question part B. Now let's do part C quickly. We have 1 minute left. Okay, so now let's take a look at part C. So evaluate the integral 2 to 4 f double prime of x dx. So over here, we only have f prime of x. What's the relation between f double prime and f prime? Derivative, antiderivative. Derivative, antiderivative. So only the FTC can relate the derivative and antiderivative together. So the antiderivative will be the f prime of x. So f prime of 4 minus f prime of 2. So now f prime of 4, we look at the table. So that will be 1.7. F prime of 2, that will be 2. And you subtract, you'll be negative 0.3. So we finished the question part C. So the answer is negative 0.3. Okay, so we make it on time. So please see the next video for the average value.